In this video, we are going to be discussing rational and irrational numbers. First off, I wanted to discuss rational numbers. We have several types of rational numbers, one of them being whole numbers. That's our counting numbers, 1, 2, 3, 4. Of course, integers, negative and positive whole numbers. Fractions, any integer-related fractions. So when we have an integer in the numerator and an integer in the denominator. Repeating decimals, and our terminating decimals. So if the number repeats over and over again in a decimal, that counts as a rational number. And if the decimal stops, like 0.25, that is a terminating decimal. Those are rational numbers. Very importantly, we need to understand a square root. So a square is an exponent of 2. And when we want to undo that square, we're going to take a square root to determine what number times itself is equal to another number. So some squares are perfect squares. They have an integer or fractional square root. For example, 144 is a perfect square. We'll talk more about the details for this later. But I know it's a perfect square because the square root is 12. 12 times 12, 12 times itself, is equal to 144. Other square roots do not have rational roots because it is not the result of an integer times itself. For example, 31 is not a rational root because there is not an integer times itself that equals 31. Irrational numbers, therefore, are non-repeating, non-terminating decimals. They're often represented by different symbols because when we have numbers that go on and on and on forever and ever and ever, we don't have time to write forever and ever, right? So some common examples are pi, 3.14. You should have learned about that last year talking about circles. We have e, which is another numerical constant, 2.718. That has to do with logarithms, which you will talk about in high school. And then, of course, we have our imperfect squares, the most important being the square root of 2. Okay. Square root of 3 is also one. Square root of 31, as I mentioned in the previous slide. Any imperfect squares that don't have a number times itself, that is a decimal, fraction, or integer, are irrational numbers. So what I want you to do is in your notes, you'll have this, this diagram. I want you to think of 2 examples for each type of number. Rational numbers as a whole, including those fractions and decimals. Integers and whole numbers are irrational numbers here. Okay? Happy learning.